Hello, this is Dr. Amudapriya, Associate Professor Tripoli, Rohini College of Engineering and Technology, Palkulam. We are discussing about the course Power System Analysis. In this lecture, we will be discussing about the power flow analysis using Gauss Seidel method and Newton-Raphson method. First, let us see how the power system buses are being classified. Generally, we used to have three different buses, namely slack bus, PV bus and PQ bus. Slack bus is otherwise called reference bus or swing bus. Here, the the real power and the reactive power P and Q are not being specified, and we have to calculate the value of P and Q. Hence, the other one, the voltage and the angle value will be specified. In generator bus or PV bus, the power, active power and the voltage will be specified with the reactive power and del being calculated. Similarly, for a load bus, which is a PQ bus, P and Q are being specified and V and del are to be calculated. By iterative method, we can easily find out how the load flow equations can be obtained. So iterative method is nothing but here we can have more number of iterations, not a single time operation. The procedure will be executed more than once. It may be user defined or based upon the manufacturer's design or based upon the consumer's capability. We used to have the iterative value. Here let us see for an example. IP is equal to summation of Q is equal to 1 to N Y PQ into VQ. So now what we are doing is that we are varying the value of Q. So the current can be calculated by having the various values of voltage and the admittance combinations. Similarly, that IP can be used for the calculation of the apparent power, which is nothing but SP is equal to PP minus JQP, which is equal to Vp star into Ip. Henceforth, Ip can be equated as Pp minus JQP by Vp star. Therefore, equating the first equation with this equation, we will be obtaining the third equation. This is a load flow equation. They are non-linear and they can be solved by the following methods: Gauss Seidel method, Newton-Raphson method and fast decoupled method. Let us see about the Gauss Seidel method. Let us have this equation to be a reference. And now for the load bus, we have to calculate V and del. So we can calculate V and del from the Vp k plus 1 equation. So now we do have this formula 1 by Ypp into Pp minus Jqp by Vp k star minus summation of Q is equal to 1 to N 1 to P minus 1 Ypq Vq k plus 1 minus summation of Q is equal to P plus 1 to N Ypq Vq k. Here we can confinedly see that we can consider the value up to P minus 1 and then we are calculating from P plus 1 to N. So specifically the value of P is being calculated here. Similarly, for a generator bus, we can calculate Qp k plus 1 in order to calculate the Q value as it is given. Now, we have to check whether this calculated Qp k plus 1 is within limits of the given Qp value. So that's the thing. If Qp calculated value k plus 1 lies within the limits of the bus P then the bus P will remain as PV bus. Otherwise, it has to be changed into load bus. So checking of Qp value is a highly important one. After that, we have to calculate the del value for the PV bus from the Vp k plus 1 equation. The acceleration value alpha can be used for a faster convergence. And next, the plus or minus values. And next, we have to calculate the change in the bus P voltage. So del Vp k plus 1 is equal to Vp k plus 1 minus Vp k. If suppose this change is less than epsilon. We have to find the slack bus power, otherwise we have to increase the iteration count and then we have to go with the procedure again. Finally, the slack bus power is equal to the summation of Sg, generation side power, minus summation of Sl, load side power. While you are considering the Newton-Raphson method, it is somewhat a different one which will be considering the Jacobian matrix. In this case, we have to consider the active power and the reactive power, and their difference is been given by the first equation. In this case, we know by with the complex one, we can consider the angle to be cos theta plus j sin theta. Here, since it is a minus one, I mean apparent power, we consider pi minus jqi. So we can consider the pi value to be with the cosine and the qi value with the sine value of the angle. Then del p del q matrix is given by the Jacobian matrix J1, J2, J3, J4 del b. So now we can calculate del p and del q from this, and this is how we are going to find out. And now we can calculate the v and del value from the following equation. If suppose these two values, del p what we have calculated here, del pik and del qik are less than epsilon, then we can stop the iteration value. Otherwise, we have to increase the iteration count. In this manner, we can easily find out the values of v and del for a case of the PQ bus. Thank you.